Hello students. So after the quick revision of module 3 and module 4, let us go to module 2. Now, quick revision means I have just taken the question paper of 2024-25 and 22-23 and that topic questions I have written and I am solving it. Okay. So this question was there in 22-23 also, 24-25 also. So what you have to do, you have to find out eigenvalue and eigenvector. And at any point of the time, eigenvalue and eigenvector is a 100% sure question. Which question they give is a different thing. But yes, find the eigenvalue and eigenvector is a 100% sure question for exam. So now let us start with this. Now, there are two ways to find out eigenvalue. One is a basic definition where the diagonal element you write with the element minus lambda and determinant you find out and get the characteristic equation. The other is a direct formula method. So let's go for the direct formula method. So what is my direct formula method? Lambda cube minus p1 lambda square plus p2 lambda minus p3 is equal to 0. Now what is this p1? P1 is trace. Trace means sum of diagonal elements. So here 7 plus 6 plus 5. Okay. So this become 11. 11 plus 7 is 18. P2 is sum of minors of the diagonal elements. Now sum of minor of the diagonal element means first when I am writing the minor of 7. So that will be hide this particular row where 7 belong and hide that particular column where 7 belong. So what is left? 6 minus 2 minus 2, 5. Plus now for 6, what is the minor? So hide the middle row, middle column. So 7, 0, 0, 5. Plus hide 5. Okay, the row corresponding to row and column corresponding to 5. So 7 minus 2 minus 2, 6. So this becomes 6 5s are 30 minus 4. 7 5s are 35 minus 0 plus 42 minus 4. Correct. So now let me solve this. So this is equal to 99. Then P3. P3 is nothing but determinant of this matrix. So 7 minus 2, 0, minus 2, 6 minus 2, 0 minus 2, 5. So take your calculator and find out its determinant. Okay. So you will find out the determinant is 162. You can use your calculator and just cross check it. Let me also cross check this value. So I am putting the selecting mat A where 3 rows and 3 columns I am picking, and then 7 is equal to minus 2 is equal to 0 is equal to minus 2 is equal to 6 is equal to minus 2 is equal to 0 is equal to minus 1 is equal to, I think it is minus 2, right? So minus 2. Okay. Then after minus 2 I have 5 is equal to, okay. Then I have to find out its determinant. So I'll do matrix calculation and then I will pick up determinant. So that is 2 and again I will go back, name it 3. That's 162 I got correct. Okay. So now I will put these 3 values here to get my characteristic equation. So lambda cube minus 18 lambda square plus 99 lambda and minus 162 is equal to 0. Now take your calculator again, go to mode, go to equation and solve this. You will get lambda is equal to 3, 6 and 9. Now how you will check this answer is correct or not? See, 9 plus 3 is 12, 12 plus 3 is 6 is 18 and the sum of diagonal elements is 18, means I am correct. Same way if you multiply this, that should be equal to 162. So this is how you can check at this step only whether you are correct or not. Now once you got eigenvalues, you have to work for eigenvector, which you have to observe very carefully because here students do silly mistakes. It's very easy but silly mistakes. So for that what you have to write? First 7 minus lambda minus 2 0 minus 2 6 minus lambda minus 2 0 minus 2 5 minus lambda. Okay. XYZ is equal to 0 0 0. This is my standard equation. Now first let me do for lambda is equal to 3. So I will put lambda is equal to 3. What I'll get? 7 minus 3 is how much? 4. Minus 2, 0. Minus 2, 6 minus 3 is 3. Minus 2, 0, minus 2. 5 minus 3 is 2. Correct? Now, you have got 3 equations from here. X, Y, Z, 0, 0, 0. Now, from here, you got 3 equations. You can pick up any 2 equations. 4x minus 2y plus 0z is equal to 0. Second, I am picking up. You can pick the third one or you can pick up the second one. Any one is perfectly okay. Minus 2z is equal to 0. Now, in this, you have to do the cross multiply. Cross multiply means x upon, hide this, now multiply these two coefficients. So, minus 2 into minus 2 is what? 4. Minus 0 is equal to minus y upon, like determinant only. So, 4 2s are 8. So, here minus 8 minus 0 is equal to z upon 4 3s are 12 minus 4 implies x upon 4 is equal to y upon 8 is equal to z upon 8. Correct? So, my first eigenvector x1 will be equal to 1, 2, 2 because I can easily divide it by 4. So, 1, 2, 2. So, I got my first eigenvector. Now, I need to do the second eigenvector. I'll just add a page here and then I'll start because I don't have a space and I have to find out 2 eigenvectors. So, just give me a second. Okay, so let's go to the second eigenvalue. So, second eigenvalue is 6. So, let me substitute now 6. So, lambda is equal to 6. I am solving for lambda is equal to 6. So, 7 minus 6 is 1. Minus 2, 0. Minus 2, 6 minus 6 is 0. Minus 2. 0 minus 2 minus 1 and again x, y, z is equal to 0, 0, 0. So, again I will take 2 equations. So, from here if I take 2 equations, my first equation will be x minus 2y plus 0z is equal to 0. Don't skip this 0, always write 0 with the variable. Second, minus 2x plus 0y minus 2z is equal to 0. Now, do the cross multiplication. I will do here only. So, x upon 4 minus 0 is equal to minus y upon minus 2 minus 0 is equal to z upon 0 minus 4. Correct? So, 4 minus 2, I got this thing. I will write here x upon 4 is equal to y upon 2 is equal to z upon minus 4. Okay. So, if I divide all these 3 numbers by 2, what I will get? 2, 1 and minus 2. So, this is my another eigenvector. Okay. 2, 1, minus 2. Now, come to the third one. The third one is lambda is equal to what I got? 9. So, I will do for lambda is equal to 9. So, now let me again substitute. So, one lambda. So, I will put 9 in this equation. Okay. So, 7 minus 9 is how much? 7 minus 9 is minus 2. Minus 2, 0. Minus 2. Then 6 minus 9 is minus 3. Minus 2. 0 minus 2. 5 minus 9 is minus 4. So, again I will write the same way x, y, z is equal to 0, 0, 0. Correct? So, equation minus 2x minus 2y plus 0z is equal to 0. Minus 2x minus 3y minus 2z is equal to 0. So, x upon 4 is equal to minus y upon 4 is equal to z upon 6 minus 4. So, this gives x by 4, y by minus 4 and z by 2. So, again divided by 2. So, your eigenvector will be 2 minus 2, 1. So, I got my third eigenvector. So, this is a complete solution of the question. See, so many steps are there. So, usually this question is asked for more marks. Okay. So, let's move to the next question. Okay. So, now you have this matrix. You have to find a to the power 4. Usually when they ask the power, they ask till find eigenvalue, find eigenvector, diagonalize it and then find a to the power 4. So, let's go through the whole process. So, the very first step is 1 minus lambda, 4, 2, 3 minus lambda. So xy is equal to 0, 0. So very first step, I should find out characteristic equation. There are two ways. One, you solve this determinant, you will get the characteristic equation equated to 0. The other way, the same formula method. So lambda square minus p1 lambda plus p2 is equal to 0. So what is lambda square will remain lambda square. P1 means sum of diagonal elements, so minus 4 lambda, and P2 means the determinant. So here 3 minus 6. 3 minus 6 is minus 3. Okay, oh sorry, sum of the minus, I skipped the central term. Wait. P2 means sum of the minus as I did over there. So for diagonal element, what are the minus here? For 1, the minor is 3. Okay, and then for 3, minor is 1. So it will become, so minus 5. 3 ones are 3, minus 4 twos are 8. So this is the characteristic equation. If you solve this, you will get lambda is equal to minus 1, 5. Use calculator to solve this to avoid the mistakes. Okay. Now let me find out eigenvector. For eigenvector, first I will do for lambda is equal to minus 1. So put here. So what you will get? 1 minus of minus 1 is 2, 4, 2, 3, 4. So xy is equal to 0, 0. So you can see you have got only one equation, that is 2x plus 4y is equal to 0. Implies 2x is equal to minus 4y. Now divide the whole equation by minus 4 so that I don't have the coefficient of x and y in the numerator. So x upon minus 4 when I am doing, so it becomes minus 2 is equal to y upon when I am doing minus 4, it is 1. Or you can think like that, ki minus 4 is coming here, 2 is going there, and then divide by the common number. So your first eigenvector is minus 2 and 1. Go to the second one. So lambda is equal to 5, right? So substitute 5 here. So 1 minus 5 is minus 4, 4, 2, 3 minus 5 is minus 2. xy is equal to 0, 0. Again, minus 4x plus 4y is equal to 0. So 4x is equal to 4y. So I can divide both equations side by 4. So my eigenvector will be 1 and 1. So by this I got a modal matrix P, which is minus 2, 1, 1 and 1, which is a matrix of eigenvectors. Now when you want to find out the power, first you need to know how to diagonalize it. To diagonalize it, you need to do D is equal to P inverse AP. Correct? Now this is P. What is P inverse? When it is a 2 cross 2 matrix, if all of you remember, just swap these two. So what you will get? 1 and minus 2. And this side change the sign. So minus 1, minus 1. And divided by determinant. What is the determinant here? Minus 2, minus 1. So minus 3. So minus 1 by 3. So this becomes the P inverse. Correct? Now, when you got this P inverse, what you have to do for this? Just substitute D is equal to P inverse minus 1 by 3. 1 minus 1 minus 1 minus 2. Then A means the given question. Okay. So my given question was 1, 4, 2, 3 and P. P is what? Minus 2, 1, 1. So you should write like this, and then we know the diagonal element. If you are sure about your answer, it is always the eigenvalues coming here and remaining 0. So this is your diagonal. If they ask the question diagonalize the matrix, you should reach till this point. But now here they are asking a to the power 4. So a to the power 4 is nothing but P, d to the power 4, P inverse. Now d to the power 4 is very easy. Here just you raise the power. So d to the power 4 is equal to minus 1 to the power 4, 0, 0 and 5 to the power 4. Correct? So now what you have to do? Just substitute the values. And when you substitute the values, you will get 209, 416, 208, 417. So you use the calculator and do this multiplication of 3 matrices, and don't change the order. And if you are not comfortable in putting 3 matrices A, B, C and then multiplying, you have A into A into a into a. That is a to the power 4. And you will get the answer. Correct? So this is how you have to do question, and most of the time they ask 2 cross 2 matrix, so don't leave them. Okay, so next question again. This question is asked in both the papers which I have, 22-23 also, 24-25 also. In one question they have, one paper they have asked only eigenvalues, and in one paper they have asked eigenvalue as well as eigenvectors. Okay, so now let's do this one. So again the same concept, my lambda cube minus p1 lambda square plus p2 lambda minus p3 is equal to 0. Okay, now what is p1? P1 is sum of these three numbers. So when I add them, what I'll get? 7, 10, 18. So p1 is 18. I'll write here. p1 is equal to 18. Okay, p2 means sum of minors of the determinant. Oh, sorry, sum of determinant of minus of the diagonal element. So this will be equal to, I'll write here so that I can express you how I am doing. So first the minor of 8 is what? 7 minus 4 minus 4, 3 plus. For 7 it is 8, 2, 2, 3. For 3 it is 8 minus 6 minus 6, 7 is equal to 21 minus 16 plus 6 3s are 24 minus 4 plus 42 minus 36. So let me solve this. So I should go to normal calculation. Then 21 minus 16 plus 24 minus 4 plus 42 minus 36. So that is giving me 31. Let me cross check this. I have a doubt on this value. And the third value when I am finding out the determinant. Okay, so if you check the determinant of this, let me go to the determinant. See my silly mistake. 8 7s I have written 42, it is 56, so it is 45. Okay, then P3 is the determinant. If you find the determinant of this, you will get it 0, right? So if it is 0, what will be the equation? Lambda cube minus P1 lambda square. P1 value I will put here. So what is my P1? 18. So 18 lambda square plus 45 lambda is equal to 0. Okay, so clearly lambda you can take common and then quadratic equation you can solve. So you will get lambda is equal to 0, 3 and 15. Correct. Now to each this eigenvalue, I should find out the eigenvector. So for eigenvector, again first the standard matrix you write. 8 minus lambda minus 6, 2. Minus 6, 7 minus lambda minus 4. 2 minus 4, 3 minus lambda. X, Y, Z is equal to 0, 0, 0. Correct? So now let me substitute the value. First for 0 I am doing. So this will become 8 minus 6, 2. Minus 6, 7 minus 4. 2 minus 4, 3. X, Y, Z is equal to 0, 0, 0. Implies 8x minus 6y plus 2z is equal to 0. Minus 6x plus 7y minus 4z is equal to 0. So here x upon 24 minus 14 is equal to minus y upon 8 4s are minus 32. Then minus become plus 12 is equal to z upon 56 minus 36. Okay, so this become x upon 10 is equal to y upon 20 is equal to z upon 20. So clearly my eigenvector is 1, 2, 2. Right? Now second one. For lambda is equal to, what is the second one here? 3. So let's do it for 3. So 5 minus 6, 2. Minus 6, 7 minus 3 is 4. Minus 4, 2. Minus 4, 3 minus 3 is 0. So x, y, z is equal to 0, 0, 0. So I'll have two equation. 5x minus 6y plus 2z is equal to 0. Minus 6x plus 4y minus 4z is equal to 0. To make it simple, you can take the third equation also. But anyways, any two equation you can take. So x upon 6 4s are 24 minus 8 is equal to minus y upon minus 20 plus 12 is equal to z upon 20 minus 36. This I am doing always. Okay. Now, this gives me x upon 24 minus this is 16 is equal to y upon minus 8 is equal to z upon minus 16. Correct? So, what is the eigenvector? So, eigenvector is 2 minus 1 minus 2. This is the eigenvector. Similarly, you can find out for the third one also. I hope now you are very clear how to do the eigenvector. So, I can proceed to next question. Now, reduce this to diagonal matrix. Now, again, reducing it to a diagonal form means again the same thing. You have to find out eigenvalue, eigenvector, then modal matrix, and then same D is equal to P inverse AP. Correct? So, now let's solve this question. Okay, so I'll do this question a little bit short. First, find out the characteristic equation. Characteristic equation will be lambda cube minus 7 lambda square plus 36 is equal to 0. So, solve it and check whether you are getting this or not. Lambda is equal to minus 2, 3, 6. And then for each one, the eigenvector will be minus 1, 0, 1. Second eigenvector will be minus 1, 1, minus 1. And then 1, 2, 1. Correct? So now this will give you a modal matrix P, which is equal to minus 1, 0, 1, minus 1, 1, minus 1, 1, 2, 1. And when you use your calculator and find out the inverse, this will be equal to minus 0.5, 0, 0.5, minus 0.33, 0.33, minus 0.33, 0.166, 0.33, 0.166. I will suggest you not to write in decimal like this. In your calculator, when you move the cursor, everything down, decimal thing will be in the fraction. So it's always better to write down it in fraction. So now diagonal is equal to P inverse AP. So when you write this directly, you can, if you are sure about your inverse and P, directly you can write down the answer minus 2, 3, 6, 0, 0, 0, 0, 0 and 0. So every step there will be a marking. So don't leave even a single step. Nicely you write everything and highlight the main results. So you will get the full marks. Let's move to the next question. Okay. Now this is a Rayleigh's method. Rayleigh's method, 100% sure, again one question, and it is easy. Sometimes it become lengthy if your starting point is not correct. So sometime in the question they will give you the starting point, and when they are not giving you the starting point, you have to use by your own choice. Okay. So now let us start with this question. I have to solve, and this question was asked in 2024-25 and it was in both the parts. It was in part A as well as it was in part B also. Means in module 1 module you have a choice always, you know. So it was there in both the methods. Okay. So now let us do this. So I'll start with the question. First I need to decide which starting point I should take. So I am taking the x0 as 1, 0 and 0. Okay. Now what is our procedure? You have to multiply this matrix A by this x0. Correct? Means you have to multiply 1, 6, 1, 1, 2, 0, 0, 0, 2 to 1, 0, 0. So what you will get, I will suggest all of you to use calculator for this multiplication. Yes, it is a single column, you can do easily. But when it comes fraction, you will do the mistake, and I don't want you to do the mistake. Okay, so use calculator, put one 3 cross 3 matrix and one you put 3 cross 1 matrix and multiply. You will observe, you will get 1, 1, 0. Okay, so now what you have to do, take out the highest value common. Since it is 1 only, so 1 and 1, 1, 0. So this is the first eigenvector and eigenvalue corresponding to it. Now you do AX1. This is your x1, this vector. Okay, so again you multiply this by 161,120,002. 110. Correct? So you will get 730. You can check 1 plus 6 plus 0. So 7. 1, 1 plus 2 plus 0. Like that. Now which one is the highest? 7. So take out 7 out. And 1, 3 by 7, 0 came. Correct? So now this become your x2. Right? Now go to the next step. Next step again a x2 you do. So 161,120,002 and you multiply this by the new x, that is 1 3 by 7 0. That's why I said use calculator. Now decimal thing came, so you have to be very particular. So now this you will get 3.568, 1.856. You have calculator, so nothing to worry about these big numbers. Now 3.568 is a bigger number, take it out. So you are left with 1.520 and 0. Means you divide all these 3 by 3.568. So you will get this vector. Okay, so this is my new vector. So now I will multiply my a with this vector. Okay, so I'll get 161,120,002 and this will be multiplied by 1 plus 0.5200 and this will give me 4 common and 1.50. Once more when I do, I'll get the same repetition. So I will stop here and say this is a required eigenvalue and this is the eigenvector. That is the Rayleigh's method. It's very simple. Just you have to put and keep on doing. Okay. So now one more question for Rayleigh's method. Again, I will start with the same 100 as my initial vector. So x0 is equal to 100. You can take 111, you can take 101, whatever is your choice. Okay. So first I do a of x0. So 4, 1 minus 1, 2, 3 minus 1 minus 2, 1, 5. So it is also very scoring and simple method. Only with calculator you have to multiply. So you can easily get good marks and it is again a 100% sure question. So don't leave this question. Okay. So when I multiply this, I got 4, 2 minus 2. Take out 4. So I am left with 1.5 minus 0.5. This become my x1. So next step I will multiply x by x1. So what I will get? 4, 1 minus 1, 2, 3 minus 1, minus 2, 1, 5. This I will multiply with 1.5 and minus 0.5. Correct? So now when I multiply and keep on continuing this process, at the end after 3-4 steps, I will get here 5.99 and 1.999 and minus 0.999. So I will round it up and my eigenvalue will become 6 and my eigenvector will become 1, 1, minus 1. So this is how you have to do the question. Rayleigh method is very easy. Take your calculator, practice multiplication of matrix, then you are done. Okay, so let's move to the next question. Okay, so module 2 is finished. In my next video, I will be uploading quick revision for module 1. So now once you are done with the whole syllabus, what you should do, you should open this video of quick revision and at every question, see the question, pause it, solve it and then again play the video and check your answer. That is what is the intent. That is how you will score more marks. So this is a check how much you have studied and how much you are pro in your all the topics. I hope you like the video, share the video and subscribe the video. Thank you.